Okay, so we will start. That day I have discussed about the saturation, right, Arham? Arham and Razi. So what is saturation? What is saturated solution?
Ma'am, the limit until a
Ma'am, it's like
solvent can fit a solute in it.
Yeah, what?
Ma'am, it is a stage where solvent cannot dissolve more solute in it.
Yes. Yeah, correct. Yes, Arham?
ma'am, I was saying that it was like when yeah, that's what I was going to say.
What? When?
I was going to say what Razi said.
Okay, correct. So what is saturation? Saturation is means if like that day I took this example, right? Ki if there's a 30 bench
Sugar
in
and water.
class,
Salt and water.
yeah, and this also the student example. And if only one student can sit in each bench, and I have total 30 benches, so only 30 students can sit in each benches, right? So what if 10 more students got admit in my class? Then what will happen? Then we won't be able to admit these 10 more students in our class. So these 10 students will sit down or they'll not be there in my class because the saturation point of my class is 30, right?
Yes, ma'am.
Yeah. Same example as this water and salt
Ma'am,
because
yesterday I like with sugar and water, like I was mixing it until I saw the saturation point.
really good. Sugar and water.
Sugar and water, yeah, not salt.
So
and
how
water.
much gram sugar?
I don't remember right now. It's written in my notebook. It's right now in my school bag.
It would be 30, 35, like max. After that, it won't.
Yeah, I think it was around like 30.
Yeah. Yes, very good, Arham. So this was the same example of salt and water that day I took that we can only dissolve 36. Hello, Advika.
Hi, ma'am.
Hi. So
Ma'am, we have this test on Monday, right?
yes, 25th. Yeah. Okay. So I was discussing this saturated solution. So what do you understand by this saturated solution, Advika? Any idea?
Ma'am, solutions that can be separated?
Separated.
Yes, ma'am.
Okay. But we can't say like separated. Okay. That day you was there, right? Or not?
I don't
No,
think so.
that day she left in the physical and chemical chain. That's what Aram told me. Advika is a physical or chemical change, Aram?
She's chemical change, no physical change.
Yes. Okay, so that day he was not there. So let me let me make you understand this one. What is saturated solution? See, let's say if in my class there is 30 benches, okay, Advika, and there are 30 students. So each
Yes,
one
ma'am.
of student can sit in this 30 benches, right? So only how many students are possible in my class?
Ma'am, 30 students.
Yeah, 30 students are possible because in each only one student can sit. So what if 10 more students got admit in my class? Then what will happen?
Ma'am, there won't be any space.
There won't be any space. So that's what I was trying to, like to explain that the 30 student is the saturation point of my class. Beyond this 30, we won't be able to got admit in my class because the 30 benches is only there and only the 30 students. If 10 or even if one more students got admit in my class, then also the saturation point of my class is only 30 students. Okay? Because only 30 benches are there.
Oh, yes, ma'am.
Yeah, just a second.
Ma'am, so the point doesn't change, right?
What?
The like saturation point doesn't change, right?
No. See, same example I took for the salt and water solution. Okay, let's say this is my beaker and and only in the 30 gram of water, only 36 gram of salt can be added, can be dissolved. After beyond this 36, if you will take 37 gram of salt, that 37 gram of salt will...
That 1 gram will be just left.
Water down?
That 1 gram will just be in the bottom.
In the bottom, it will settle down. It will not dissolve because the saturation point of my water is to dissolve only 36 gram of salt, not more than that, not even 0.5 gram more than that. Okay, so that's the saturation point. Understood?
Yes, ma'am.
Okay, so today I'll discuss about the what is unsaturated. What is
Yes, ma'am.
unsaturated solution? So the definition of the unsaturated solution is a solution that can dissolve more solute in it. A solution that can dissolve more solute in it. More solute in it at a given temperature. At the given temperature is called unsaturated solution. Now, what is the meaning of this? A solution can dissolve more solute in it. For example, more solute in the sense that the capacity is not crossed. That's why it can dissolve more solute. It's not like it will dissolve 38 gram of salt in the water. No, here the capacity
Ma'am,
is not. Yes.
ma'am, here it means that the solution has not reached its saturation point, no?
What?
Ma'am, here it means that the solution has not reached its
Yes.
saturation point.
Yeah, correct. Here the capacity is not crossed. That's why it can dissolve more solute. That's why it can dissolve more solute in it. Like for the example, a maximum of 36 gram of common salt contains what? Matlab like only water can dissolve 36 gram of salt. It's a fixed value. Okay. Suppose we now dissolve, let's say this is my beaker, there is water, and let's say this is my spoon, and I dissolved only 25 gram of salt in this water. Then what will happen? The solution, then what will happen? Ki it can still dissolve more 11 grams, right? That's why I'm saying here unsaturated, because a solution, this is my water solution, that can dissolve more solute in it. Solute is my salt here. It can dissolve more solute. Like, for example, 36 gram is the capacity of water to dissolve a salt. If I dissolved only 26 gram of water, then what will happen? The 11 gram is left. So that's why it's saying ki a solution that can dissolve more solute. It's not like it will, it will go beyond its capacity. No, the 36 gram is fixed. It's like the capacity is not crossed. That's why it can dissolve the more solute. It's only like the, if I'm dissolving the 20 gram, then how many left? 36 minus 20 is 16, right? 16 gram is left. If I'm dissolving 10, then some gram is left. So the capacity is not crossed. That's why it can dissolve more solute. If the 36 gram of capacity is crossed, then obviously it won't be able to dissolve the solute in the solution. Okay, understood. Something.
Yes, ma'am, I understood.
Ma'am, I got the basic idea. Ma'am, can you
Okay.
like explain it little
Uh,
again?
Yeah. I'll explain. But first of all, Razi, will you explain us? Explain Advika and Arham. Try to explain.
Yes, ma'am.
Huh.
Ma'am,
Very good.
unsaturated solution is a solution that hasn't reached its saturation point. It means that you can dissolve more salt or sugar in it.
Yes. The capacity is not crossed. That's why it can dissolve more solute in it. Because if example 37 gram of salt, if I want to dissolve in this water solution, then obviously it won't be able to dissolve, right? Because 36 gram and 37 gram, 1 gram is crossed, right? So
Yes, ma'am.
the
Yes, ma'am.
capacity here, only the capacity is not crossed. That's why it can dissolve. Here the definition is written, a solution that can dissolve more solute. More solute in the sense that capacity is not crossed. That's why it can dissolve more solute. It's not like it will dissolve more than 37 or more than 40 grams. Okay. Arham,
Yes, ma'am. Got it.
Advika,
Yes, ma'am. Ma'am, I got it.
basic concept got it?
Yes, ma'am.
Only like the capacity one is not crossed. That's why only it can dissolve. If capacity is crossed, then obviously it
Ma'am,
won't.
then it'll dissolve. Ma'am, then it will dissolve, right?
No, if the capacity is crossed, like 37 gram is the
Ma'am, because
capacity.
then it'll stop dissolving because
Huh.
it can't hold,
Yes.
it
I
crossed the
can't hold
limit.
more.
Yes,
Yes,
very
ma'am.
good.
Ma'am, there's no more space in the whole solution to dissolve more of the liquid, of
Yes.
the more of the solid.
So if the capacity is crossed, it won't be able to. And if the capacity is not crossed, then only it will be able to, dissolve the solute in the solution. Okay, so saturated solution and unsaturated solution. The like explanation, matlab, clear, right?
Yes, ma'am.
Okay.
And
Any
also, you said when you mix the water, you know, that unsaturated becomes saturated and
what?
saturated becomes unsaturated.
What are,
But you also said like when you mix the water, like it become unsaturated, like that.
okay. Okay. So Razi and Advika, any doubt in the saturated and unsaturated?
No,
No,
ma'am.
ma'am.
No,
Okay.
ma'am.
Ma'am,
And
so ma'am, can I just have a doubt, ma'am? So in saturated solution,
the,
ma'am, the whole liquid, ma'am, do you, ma'am, does it like, ma'am, sugar solution is a saturated solution, right, ma'am? But for that, you don't require to heat it or do any energy at all. It just dissolves automatically.
yeah,
Yeah, you have to mix it.
now we have to mix it, it would dissolve automatically, right?
Yeah, it
Yes,
does.
ma'am. Yes, ma'am.
But the capacity is also there. Only the
Yes, ma'am.
100 gram of water
Ma'am,
can
only
dissolve
100 grams can dissolve. Ma'am, for salt,
36.
it's 36. Ma'am, and if you add more of it, then it only 36 gram of it will dissolve, and the rest will not dissolve, right?
The rest will settle down. Okay.
Yes, ma'am. Yes, ma'am.
Okay. Good. Now next one is super saturated solution. One more topic is there. The last topic of this chapter. Where should I write? Let me write it here. Yes, the super saturated solution. Now, what do you understand by this super saturated solution? Any idea? Anything? What is super saturated?
It means like
Uh,
I have no idea.
any guess?
No.
Ma'am,
No.
I think there is more solute dissolved in the solvent as
Yes.
compared to its saturation point.
Yeah. Good.
That's
Okay.
what I was thinking.
Okay, so chalo, let me explain. See, if here, let's say this is my beaker. Okay, 100-gram water is there in my beaker, 100 gram of water, and if I'm dissolving 37 gram of salt, okay, 37 gram of salt in the water, then what will happen? Obviously, the 1 gram of salt will settle down, right? But we don't want this in this super saturated solution. Why? Because see here, anyone?
Yes, ma'am, I'm there.
Okay, so so what we will do, we will we will increase the temperature. Okay, this is the very the important point of this topic of unsaturated. What we will of the super saturated, what we will do, we will increase the temperature. We will increase the temperature. Then what will happen? The kinetic energy will also increase. The kinetic energy will. This is the symbol of the increasing one. Okay. See, what will happen? Will increase the temperature. Then the kinetic energy will also increase. Then what will happen? Let's say. Then what will happen? The intermolecular force of attraction is weak in the liquid phase because of this intermolecular particle spaces is more, right? The intermolecular, let me write, then I'll explain. The intermolecular forces of attraction is weak in this liquid phase, especially is weak in liquid phase. Agree, everyone?
Yes, ma'am.
Okay, so the intermolecular force of attraction is weak in this liquid phase. So what will happen because of this weakness of the weakness of this force in this liquid phase? Then what will happen? Because of this, interparticle spaces will be more. Interparticle spaces will be more. So what will happen? Suppose we are giving heat. Okay. Then what will happen? The kinetic energy will also increase. Then the particles will move here and there. Particles will move. The 36 gram, the 35 gram, which we have already, total was 36. The 1 gram was settled down. But so if we will, increase the temperature, the kinetic energy will also increase. So if kinetic energy will increase, then what will happen? The intermolecular forces of attraction is weak. That's why the particles spaces will be more. So here one particle, here one particle, here one particle, here one particle. So because of this, what will happen? The spaces will be more. So this my 1 gram will get some space and it will get dissolved in the solution. The very easy one. Okay, wait.
Yeah,
Let me
come
come.
on, got it.
Got it? See, so what is supersaturated? If I'm taking 100 gram of water, okay, 100 gram of water and 36 gram of salt. So,
37.
sorry, 37 gram of salt. Then as per the saturated solution and unsaturated solution, obviously my 1 gram will not dissolve. It will settle down.
Settle down.
Right. So this is the super one. So some super energy will be there in this solution. What will happen if we will increase the temperature of this beaker of this, of this solution? The kinetic energy will also increase. So because of the increasing of this kinetic energy, then what will happen? The intermolecular forces of the attraction is very weak in the liquid phase, okay, as compared to the solid and the gas. The intermolecular attraction is very weak in the liquid phase. Then what will happen of this weakness? What will happen? The spaces will be more. So if more spaces will be there, then this 1 gram will easily go and dissolve in this solution. Let's say this is my beaker. If there's my 35 gram of salt is dissolved like this, and 1 gram is here. So obviously there are more spaces, right? Because of the kinetic energy we have already increased. So more spaces is there. So 1 gram will go. Yes, Razi.
Ma'am, if we increase temperature, the saturation point will also increase.
We will increase the temperature. Why saturation point will increase? No.
Ma'am, there won't be a change, ma'am, because saturation, ma'am, because the quantity of the solute and solution is not changed, right?
What?
Ma'am, how does it make a difference if we're making any change in it? Because the quantity of the solute and the solute and solute isn't changing. That's why.
What happened? Are you fine? See, here by increasing the temperature, the kinetic energy is increasing. The kinetic energy is increasing. That's why the spaces are more. So spaces are more. So 1 gram.
I'm sorry, and I got a cough in the middle.
That's why. It's okay. So that's why the 1 gram can easily go and dissolve because the spaces are more. So 1 gram will go and easily dissolve in the solution because of the increase in the kinetic energy. We have already increased the kinetic energy because of the increasement. The spaces are more, and if the spaces are more, then obviously 1 gram of water will go and 1 gram of salt will go and easily dissolve here and there. Right? Right? Arham, you got this part?
Yes, ma'am, got it.
Okay, can you explain, Arham?
Ma'am,
Hmm.
ma'am, it's like that. Super saturated solution is like when it's over the saturation point. So like 100 grams of water and 37 grams of salt. So 1 gram will be will be unsaturated. So
Ma'am, is there a saturation point for mixing of liquids?
Saturation point of mixing the
liquids.
Two liquids.
liquids like what?
Ma'am, milk and water, like if I'm mixing them, is there any saturation point that you can only mix until one limit?
But milk and water won't dissolve, right? They will mix.
Mm, but still, is it like any point or any quantity where you can't just mix them anymore?
No, it's not like that. No.
Ma'am, so any amount of water can mix with any amount of milk?
Yeah, we can say, but we have to check like how many milk we are putting. So at that point, okay, how many milk we are putting and the milk is not dissolving in the water. We have to, we have to pour it, and then we have to check, okay, that this gram of milk will not be able to dissolve in this gram of water.
So there is.
What?
So there is a saturation point.
There should be, na. Like, if we will apply our logic, then there is or there not.
Most likely, ma'am, like milk will not dissolve in water.
What?
Milk will not dissolve in water.
Milk, yeah, yes. The fat particles is there in the milk, right?
Yeah.
Because of that fat particles in milk, the milk will not dissolve in water.
Yes.
And milk is also a colloidal solution. That I was discussed now, the colloidal solution. This is
It's called the Tyndall effect, right?
Tyndall effect. Yes. Yes, Aram. It causes the Tyndall effect. So Milk and water will not dissolve. That's why the saturation point we can't say.
Okay.
Okay, Advika. Okay,
Ma'am.
so the concept of the super
Ma'am, can I
saturated.
drink? Ma'am, can I quickly drink
Can
water
I
and come back?
Sure.
can I tell super saturated solution?
What is that?
Can I tell a super saturated solution? You
What?
asked me to tell, right?
Chalo, tell me.
So like super saturated solution is like when it's above the saturation point, like 100 grams of water and 37 grams of salt. So it's not the 1 gram of salt will not be able to will not be able to dissolve in the water
Yes. Why? Because
because it's over the saturation point.
but in the super saturation, the 1 gram of salt can easily dissolve in water, right? But how?
Yeah, it can dissolve in water, but then the particles that are dissolved in water will be not dissolved.
What?
Like where it the not
Okay. Wait.
the
Just
1 gram will get dissolved, but the part that is dissolved will undissolve.
No, it's not like that in the super saturated, Arham. Razi, wait, Arham. Razi, you got this concept of the super saturated or not?
Yes, ma'am.
Okay, explain it.
Ma'am, when we will increase the temperature, ma'am, the kinetic energy will also increase with the temperature, and the intermolecular force or intermolecular spaces will increase in the solvent, and the salt will take place of the molecules.
Yes. Yeah. The spaces will be more than we can easily dissolve 1 gram. It's not like Arham ki the undissolved will get dissolved and the dissolved will get undissolved. No, that's not the concept in this super saturated. In this here, the dissolved, sorry, the undissolved will get dissolved. It's not like the reverse one. Only the undissolved will get dissolved. Here my 1 gram of salt is undissolved, right? So how
Yes,
it will get dissolved? Because of the increase in this kinetic energy. If we will increase the kinetic energy, then the forces, intermolecular forces the spaces will be more. Because of this spaces will be more, we can easily dissolve the undissolved salt solution in the dissolved particles in my solution. Okay, it's not like the dissolve will get this undissolved and the undissolved will get dissolved. No, this concept is not in this. Okay, here only the undissolved will get dissolved. Why? How? Through the process of this kinetic energy. This is the main role in this super saturated solution. The super one is the kinetic energy here only. That's why. That's how they are getting the the spaces. Then only the 1 gram will get easily dissolved. Okay, Adam.
Yes, ma'am,
Advika?
got it.
No, she's not there.
Ma'am, I've got to drink water.
Yes. So, Advika, you explain me this super saturated solution. Which is
Ma'am,
on?
1 second. Ma'am, I have a small question. Ma'am, so
Uh-huh.
ma'am, super saturated is basically like a saturated solution, right?
No, the super saturated solution is not a saturated solution. Why?
Ma'am, but
Because
it's
uh, sort
super
of.
saturated.
No, sort of also we can't say here. Why? Because in this saturated, we won't be able to dissolve 37 gram of salt. It's impossible here. It's beyond its capacity. But in this super saturated, we are able to dissolve 37 gram because of this kinetic energy. Because if we are increasing the temperature,
But in a super saturated solution, we can dissolve more than that, right?
yes, we can dissolve beyond its capacity here. But in
Yes,
this
ma'am.
saturated, we can't dissolve it beyond this 36 gram of salt capacity. Okay, but here we can easily dissolve. Yes.
ma'am, super saturated solution. We are giving quite heat energy so that
What, Razi, your voice is not coming?
ma'am, is it clear?
Yeah.
Ma'am, in saturated solution, we provide heat energy to the solvent so that it can dissolve 1 more gram also, no?
Wait. Advika, will you please switch off your mic? Sound is coming. Okay, yeah, Razi, come again.
Yes, ma'am. Ma'am, in super saturated solution, we provide heat energy to the solvent so that it can dissolve 1 gram more salt.
Because it can
Ma'am,
dissolve.
and in saturated solution, we do not provide any energy, na?
No, we do not provide any super energy here. Only in super
Okay, ma'am.
saturated only we provide this super kinetic energy. Okay.
Okay, ma'am, I got it.
Okay. So in this saturated one, no super energy, no beyond its capacity one is going. Unsaturated one is the easiest one. The capacity is only not crossed. That's why we can dissolve here more. And in the super one, we can dissolve more and more beyond its capacity. How? By increasing the temperature, by increasing the kinetic energy, these spaces will be more, so it can dissolve.
Ma'am, but you just said by increasing the kinetic energy, by increasing the temperature, the saturation point doesn't change.
We will increase the temperature. Yeah, the saturation point will change. Then only the 37 gram of salt will easily get dissolved here, right? The saturation point is changing here. That's why the 37 gram or 38 gram or 39 gram of salt will easily get and dissolved. If saturation point is only not changing, then how we can dissolve here? Because of this increasing the temperature, the kinetic energy is increasing. Because of this kinetic energy only we are dissolving beyond its gram of anything, sugar, salt, anything. Okay,
Yes, ma'am. Got it.
got it, Arham?
Yes, ma'am.
Okay, just a minute. Okay, yes. So with this, our chapter is done. This chapter is completed as matter around is pure. Now let's quickly recap. Because Monday you guys will have test. Very easy paper. No, it's not that easy, but yeah.
But it's easy. Yes, ma'am.
Yeah, what? It will be easy, but the thing is, you have to go through all the, all through this my notes, all the, all the points. Then only you will be able to.
You're saying we have to prepare. At
Yes,
least.
You
ma'am.
have to prepare with this notes. With
Yes,
this
ma'am.
note, everything will be clear. Then you will be able to attempt all the questions 30 out of 30. Okay.
30 questions.
No, not that. 12 questions. Total mark.
How many questions are there, ma'am?
12. 1 to 5 contains very short answer, only 1 marker each. The 6 to 10 will contain maybe 5 or 3. And the 11 and 12 only 2 questions contain 5 marker and 5 marker. Okay.
Okay, ma'am.
So let's do quickly recap. So matter is of 2 types, pure matter and impure matter.
Pure matter.
And in pure matter, we have 2 things, elements and compounds. Okay, wait. Any doubt in the assignment? A1, A2,
No, ma'am.
A3, any doubt? No doubt. Razi and Advika.
Ma'am, I think I have a doubt, but I don't remember which. I don't
Okay,
remember.
go through and ask. Check once and ask. Razi and Advika, any doubt in any of the assignments?
No, ma'am.
No? Okay. Razi? Razi, what about you? Any doubt? Okay, Razi is not there. Okay, so Adham, you check. So matter is of
Which assignment?
which assignment? A1.
Oh yeah, it was on the older one.
Older one?
Yes.
Acha, an older one.
Yes.
Okay. You send me, I'll clear.
I clarified already, I think, with my mom.
You clarify? Okay, chalo, good. Okay, so let's go through quickly. Matter 2 types, pure matter, impure matter. Pure matter consists
Pure
of
and impure.
particles. Impure consists of 2. Coffee, we can say coffee is an impure matter. Why? Because coffee is a combination of the milk, of the, of the tea, of the sugar, of the caffeine, right? So, okay. And pure is like consists of only 1 particle, like water. Water is a pure because only H2 is everywhere. That's why water is a pure particle. And what is pure? Pure consists of 2 elements and compounds. What is element? Simplest form of matter that cannot be further divided. It's an element. And compound. Compound is a mixture of 2 or more elements, is known as compound. Right? Now, here, yes. The pure also known as the mixture. Yeah. The impure is also known as the mixture. Impure matter, impure particles are also known as the mixture. Okay, so matter, pure, impure, pure element and compounds, and the mixture means the impure one. This is basically the impure. Impure is further divided into 2 types, the homogeneous and the heterogeneous. Homo means same, hetero means different. Homo means same phase, hetero means different phase, like salt and water is homogeneous, but sand and water is hetero because
it won't mix.
It won't mix. Okay.
Ma'am,
Water
oil and water.
is what? Is homo or hetero?
Hetero.
Good. Okay. Next, elements. See, the pure matter, pure, impure, pure element compounds. Now again, elements is categorized into three types: the metals, non-metals, and metalloids. Okay. Metals, iron, non-metals, salt, and the metalloids, boron. Okay. So now one more thing here: the pure element. Pure is also consists of two types: the mixture or compounds, or we can say the elements or compounds. What is mixture? Mixture is also the same. The mixture of something, the mixture of compounds, right? Mixture of compounds, mixture of too many compounds, we can say it as a mixture. And what is a compound? Compound is a combination of two or more chemical elements. Like here, if I'm combining the water, H2O. So here, my two H is there and only one oxygen. So it's what? It's a combination of various elements, right? H2O.
Yes, ma'am.
Razi, okay, yeah. Razi, are you there? Okay. So likewise, the CO2, carbon, and the
Ma'am,
oxygen.
I can't see your screen anymore.
You can't see my screen. Arhan, my screen is not visible.
Ma'am, it is visible.
Okay, well, let me come again. Yes. Now it should be.
Ma'am, now it's not.
Ma'am, now, sir, I
Mm,
can't.
We can't see.
Okay, now.
Yes,
Oh,
now.
yes, ma'am. That's fine. Ma'am, I can see it now.
Okay. Now you are seeing. Okay, sorry. Pure is divided into two types: mixture and compounds. Compounds you already know, two or more types of elements. Malab combination. H2O, carbon dioxide, water, everything is type of a compound, right? Here, the salt water is a homo. Chocolate milk is a heterogeneous,
True.
right?
True,
What
ma'am.
salt plus water is obviously a homogeneous. So yes, Aram.
No, I said
So
salted water is homo and chocolate milk is hetero.
water is hetero. Okay. So this part is clear about matter, about elements, compounds, mixture, hetero, homo, metals, non-metals, right?
Hello?
Now,
Hello.
yes, Razi, yeah.
Ma'am, can you hear me?
Yes. Where were you?
Ma'am, I went to somewhere when I came. I was saying something and you can't hear me. You were not
Okay,
able to hear me.
yeah, maybe network issue. So I was discussing this only, the matter types, the elements, and the compound types. Okay.
Heterohomogeneous. The heterogeneous, homogeneous, that's used.
Yes. So next, this only the same thing. It's there in this notes. The elements, metals, non-metals, compound. Go through all this notes, okay, and be
Okay.
prepared for Monday. And
Okay.
what about this? This is what the homo hetero. The elaboration of this homo hetero. Homo is a true solution. Hetero is again divided into two types: the colloidal solution and the suspension solution. See here, the colloidal example is milk. Okay.
Okay, ma'am.
Okay. So true solution is what?
Colloidal solutions applies Tyndall effect, right?
Yes. Here. The colloidal solution. True solution. Tyndall. Okay. Okay. So true solution is transparent particles cannot be separated by the filtration. Cannot. Okay. Particles cannot be separated by filtration. Okay. Example: salt water, and the property is does not scatter the beam of light. Only the does not scatter the beam of light. Like here, this is my true solution. True solution is not able to scatter the beam of light, but the colloidal solution is having the property of colloidal is having the property of scattering of light. Okay. True is not having this property. Okay. Colloidal is translucent and suspension is opaque. Here particles cannot be separated by filtration, same as true solution. Here particles can be easily separated by the filtration. Like here, salt plus water is the correct example. This we cannot be separate by filtration process, but sand and water we can easily separate by this filtration process, right?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So this was what? The solvent. Okay, the aqueous solution, non-aqueous solution, colloidal suspension. Acha, haan, that day I told na this. Ki what is solid in solid solution, solid in liquid solution, solid in gas solution. You have to go through all this. Okay.
Yes, ma'am. I have it in my book.
The next part, these are the okay. Two maybe numericals is there in test paper. Two maybe. I don't remember. Yeah, two or one. Okay, so this numericals. This is the question, right? Question numericals. Numericals example questions. Say. Okay, so remember this formula. Formula is very easy. If mass by mass, then mass of solute. Mass by volume, then this. Only the denominator part is converted from mass to volume. volume by volume, then both the numerator and the denominator, volume and volume.
Ma'am, what is
Suspend
the time of the exam?
time 4 to 5:45, I guess, 1.5 hour. Yeah. Okay, so this is same as suspension. And the next one, okay, yeah, the liquid gas colloidal solution. Again, the same. What is this? Acha, हाँ, this was also there. Na?
Filtration.
Yeah, the evaporation, centrifugation, chromatography, evaporation, separation, distillation, separation. Oh yes, fractional distillation. Okay,
Yes, ma'am.
so these all are there.
Ma'am, these are there in Drive also, right?
It's there in Drive.
Okay.
And it's there in the group also. 9 and 10th group I've already sent. The crystallization, what is the difference between the crystallization and evaporation? In crystallization, we get the actual crystal, but in this evaporation, we won't get the actual crystal because of the evaporation part. है ना?
Yes, ma'am.
And this was our last topic, the physical and chemical.
We won't get like completely pure.
Yeah, in the evaporation. But in crystallization, we'll get
We'll
complete.
get completely pure.
Yes. Chemical changes, physical changes. Chemical is original substance loses their identity. The new substance cannot be reversed.
Ma'am, today I did a chemical change.
How?
Today what we did, like my father and I, we put sugar on the stove, that stove thing, and then it just turned into carbon.
So that change is not reversible, means that's a chemical change.
Yes.
Okay, that thing loses their identity, right? It converts into a carbon.
Carbon.
Yes. And what is physical? Physical change is
Physical
easily
change is reversible.
Like ice, salt solution, apple. Okay.
After cutting
And
it.
the last one was saturated, unsaturated, and supersaturated. Okay. Anywhere, any doubt?
No, ma'am.
Okay. Razi. Okay. Chalo. It's already 6:45. Thank you.
Okay,
Be
ma'am. Bye,
prepared.
ma'am.
Yes.
Bye, ma'am. Thank you, ma'am.
Bye. Thank you.
Bye, ma'am.